Is it sharing? Okay.
It is presenting the Google Meet, so yes, I can see it.
Okay, cool.
All right, you can go ahead.
Okay, great. I'll get started. I'm just going to turn on my camera for a second so you can see who I am. If it shows anywhere. Anyway, maybe with presenting it won't show me, but maybe it does. So anyway, I'll turn off my camera in a second. I just wanted to say hello. Firstly, thanks for joining this session. I don't know if you're forced to, but it's great to see you here. So my name is Paul. I work with the Human Sciences Research Council, and I manage a project called Policy Action Network. Okay, cool. Good to see you. Well, you can see me. I can't see myself, which is probably good. So I'm going to be presenting, I suppose, half a session with Mabu, who's going to be talking on the more technical parts of big data and AI. I'm going to start off with a bit of a government 101 and a bit of a challenge brief on the more election-focused challenge that we proposed together with Mr. Tselani, who presented last night from IEMSA, which is a company that runs election management for a number of organizations around the country. So together with them, we are supporting lead-up events to their AI and Democracy Election Summit that should be happening later in the year. And we're encouraging people to work on election and democracy-related projects that can then feed into that summit at the end of the year, which should be held in Cape Town, but it will probably be a mix of virtual and in-person conference in Cape Town. But anyway, we'd be keen to see if some developers, project people can present at that summit, depending on what comes out of the hackathons. So anyway, we are looking out for ideas and projects that could feed into that process and just to showcase what developers and entrepreneurs are building in the space in South Africa and Africa as well. But anyway, as I said, from my side, I'm going to do a quick government kind of 101 very briefly, and then also speak about a couple of other things. The one is, and I don't normally do this, but I wanted to show a little bit of the procurement type opportunities in the government space. I know you might be a bit cynical about this, but as a longer term view, I think it would be great if you had a sense of how some of the government kind of software related procurement looks and what you might bid for in future. And potentially if you end up working in government or you are working in government, the types of projects that you might be contracting or implementing. So I did want to show that briefly. And then as a third thing, I'll also just highlight the challenge brief on the elections challenge and some of the data sources related to that you might want to look at if you're going to do that challenge. So just as a first point, from a government perspective, there's one thing I just wanted to highlight, and it might be obvious to you, but I just want to make sure we're all on the same page. So as you know, essentially in government and the broader state, there's kind of three parts to the state. There's the judiciary, which is essentially the courts. There's the legislature, which is the people who make the laws effectively. And that's usually the National Assembly who sits in Parliament. And then the third part is the executive, which is essentially the part of government that implements service delivery and builds infrastructure like roads. So the one that's of most interest to you probably is the executive, because that's the part of government that actually does stuff. And from a software and data perspective, they are the ones that procure services and implement projects. So in the executive part of government, there are three what are called spheres in South Africa. So you might know them as national government, provincial government, and local government. It's a little bit more nuanced, but I think that's enough for now. So you are probably familiar with some of the big national government departments. One of them is the Department of Home Affairs, so they manage things like ID, your ID books and things like that, passports, those kind of things. So that's an example of a national government department. Then in provincial governments, that's where all the big healthcare and education service delivery happens. So almost all the schooling that's delivered through government is through provincial government. So if you're ever worried about school-related things, or you're interested in education-related things in primary and high school, then that is something that you would engage with your provincial government about. And then the third sphere of government is local government, and that's your municipalities, and usually the municipality that you live in, you would speak to them about things like water supply and electricity supply, and also municipal roads to some extent. Sometimes your electricity supply comes from an organization directly from Eskom, but in other cases your municipality is often sitting between Eskom and yourself and supplying electricity. So it's just important, and I wanted to highlight that. That's all I'm going to mention about government really, is that you need to understand who you're engaging with. So if you're looking to work on education-related projects in the dev or data space, then you probably want to engage with provincial government. If you're wanting to work on electricity or water supply-related projects, so for example, monitoring water supply, then you probably want to engage with the municipality. So just in the back of your minds, if you can keep in mind who you are likely to be engaging with when you're looking to engage with government, and specifically the executive. Just for the purposes of this hackathon, I did just want to mention again what's happening with elections. So the last local government elections that happened, which is to elect people to municipalities and local governments, and that happened in 2016. The last provincial national government elections were essentially 2019. So that's where we elected the current, well, effectively elected the current president. So that's national and provincial government. And then the next local government elections is happening this year. So that's why there's a lot of interest in what is happening around elections, and specifically local government elections, so your municipalities. So if you're interested in elections for this year, you might want to look at municipal or local government related topics, because that's the focus of the elections for this year, is local government. And that includes things like electing your ward councillors, and that effectively also results in the appointment of new ward committees and things, and new ward structures down the line. So anyway, I just wanted to mention that from an election perspective, because I'll be getting back to that just now. What I did want to then highlight, and I'm going to stop my camera, is then the second part of what I wanted to comment on was around opportunities in the government space. As I said before, a lot of people only believe you can get government work if you have connections, etc. But I think the more entrepreneurs and developers that are kind of engaging with the municipalities and submitting proposals and getting interested in government procurement, I think the more that there are better options for government to procure better services. So I have personally, with my own business, I've bid for government work and been successful in getting government work. And I think a lot of you could either do that now, or in the next few years be bidding for government work and getting contracts. But I think it's important to understand the different kind of levels of procurement in government, and that you're not necessarily going to be bidding for things like a 50 million rand tender outright. You need to build up a bit of a track record, the same as you would with the private sector, and some experience in the space before you bid for those larger contracts, which are normally called tenders. And that's what you probably hear most about in the news, is around tenders. So what I'd recommend is that you start looking, if you are interested in the space, is to start bidding at lower level contracts, which are normally in the municipal space called RFQs, or requests for proposals. So, and those RFQs can be anything from 2,000 Rand to approximately 200,000 Rand, usually around 2,000 Rand, depending on the rules. So between 2,000 Rand and 200,000 Rand contracts, there's quite a nice opportunity space for small entrepreneurs to do projects like website development, basic software-related work, training-related opportunities. So that's the space as emerging entrepreneurs and developers. If you've got a business and you've gone through a couple of registration steps, it's something that you might want to consider. So I just want to show a couple of examples quickly of what those might look like. So I'm hoping you can see, just let me know if you can't right now. But I wanted to show you what a typical RFQ looks like, which is a smallish tender. Well, not a tender, and this is where sometimes it'll get confusing on municipal websites, but usually it's called a request for quotation. So if you go to a municipal website, there's usually a part of the website, as you can see here, and just let me know if you can't see, someone please shout. But you'll see there's usually a tender page where you can see different categories. So if you go to, for example, this is Buffalo City, and you want to see what they have available under their request for quotations, which is their smaller ones, you can see formal tenders are there, but those will be the bigger ones, which as a small entrepreneur, I'm probably not likely to win. But what I would look for is something like formal request for quotations, because those are the smaller contracts. So if I click on that, and in this case, I'm just going to go to 2020 to show you an example that happened then. So if I look under their list of tenders, I can see, under the list of requests for quotations, I can see an opportunity. You can browse through them, but I've already looked at one. You can see if you go through the list, there's one down here, which was, I think, November last year. Buffalo City was looking for a software solution for resort reservation management system. So if you just download the RFQ, I'm not going to do it, I've already downloaded, so I'm just going to show you. You can go into that, and if you open the PDF, you can see there's a request for quotations for a software solution. So because this is an RFQ, I know that the kind of maximum budget that they're allocating for this is around 200,000 Rand. So it's a relatively small project, but it's something that as a small entrepreneur, I've got a good chance of winning. So you can see they only advertised the advert is only open for about a week. So again, that's an indication that it's quite a small request. And then there's lots of kind of administrative stuff, which looks really bad, but I just want to say, once you've done it once or twice, you get used to it, and you pretty much copy and paste to your later RFQs. So you shouldn't be put off by a lot of the admin. And it's good practice for if you're bidding for private sector contracts or other types of funding, because they all have some kind of contract. So it's worth getting used to just looking at contracts. So I just want to show then, usually if you browse down through the RFQ description, kind of late in the document, there's usually the scope of work, which tells you what they want to do. And in this case, Buffalo City is looking for a resort management system that can allow people to make reservations at their resorts around the city, and to do things like scheduling the date and length of stay, making deposit payments, cancelling bookings, all that kind of thing. And then obviously some technical things like database integration, etc., and what technical requirements. So they want a Microsoft platform and Microsoft SQL, so they want people who work with that. And then they want some maintenance support as well, and things like that. So anyway, this is an example of a small RFQ that, as an emerging entrepreneur, if you're based in Buffalo City especially, we would like to encourage more people that are living in, say, East London to bid for these kind of projects that are smaller, and you have a reasonable chance of winning as an emerging entrepreneur, and maybe you've got a few projects under your belt, and if you can price it if you can price correctly, there's a good chance you can win that. Similar, I mean, there's over 200 municipalities in the country, and they're all issuing RFQs of a similar kind. This is an example from the Eastern Cape, and this one's on training on advanced Excel. So you might want to get into the Excel training space as an example. And you'll see it's similar kind of stuff. Lots of admin, and then later in the document they talk about what they actually want to do. And usually you have to kind of go all the way to the bottom, and you'll see that they want to, if I can find it, they want someone to do training on things like on advanced Excel, but then they specify stuff like, for example, applying number formatting, printing and preview and printing a workbook, lots of odds and ends related to essentially Excel type work. So if you analyzing pivot tables, so these are all typical things. If you've worked with data and Excel, you're probably quite familiar with. So there's a good chance that you would be able to package a training course for this kind of thing if you're into the training space. In some cases, they might require you to be a certified trainer. And then just one last example, this is from eThekwini municipality. So again, if you're based in Durban municipality, this one is for maintaining and upgrading the Durban tourism website. So that's quite a nice web development one as an example, and they want someone to essentially rebuild the visitdurban.travel website. So this one is a tender, it's a bit larger, so you're probably looking at about a million or 500,000 Rand plus, or 200,000, more than 200,000 Rand budget on this project. So they're probably looking at quotes between 200,000 and a million Rand for this kind of project, where essentially it's a website redevelopment. So again, this is something that you might consider once you're a little bit more established. Okay, so I just wanted to mention that because I'm really keen on encouraging people, especially emerging entrepreneurs and developers, to look at government web and data related projects that you could start bidding for. And as I say, you might not be successful in the beginning, but over time it's good practice, and it helps you when you're bidding for private sector contracts as well. Just learning the skill of developing proposals. And if you're ever interested and if you need help, I'm always willing to help people with building their proposal content and things like that. And there probably are lots of other kind of mentors who are willing to help you with setting up your proposals and bidding for government work. Because it's not something I'm doing these days, because I am working in government. All right, so then the last thing I wanted to mention as part of my quick session is that we are kind of co-sponsoring or curating the challenge related to AI, big data, and democracy for this hackathon. So if you are planning to work on this one, we've done a little challenge brief, which I think Tiani has shared on Slack. And you're obviously welcome to ask me any questions that you might have about it. But essentially, we're just looking for people to develop their own ideas or to work on some of the kind of topics that we've proposed in this one-page brief. So the one topic we've proposed, which we think is quite important, is women's participation in politics and government. So this one, you might work with data related to, for example, political party candidates, or also voters that are participating in the election. So one of the links we've provided is, for example, to the IEC website. And strangely, they've updated this probably in the last 2 days. So they've got a slightly new format to the data that they've got available. But here they have the voter registration statistics, and actually this was updated, probably could have been this morning, that they've put up the new site or new page. But essentially they've got data on all the different provinces, and it seems even municipalities, on who has registered by what age group and gender. So you might want to analyze that data In this case, I don't think there's a download option. There is an API, although things might have changed as of last night, but there is an API. I think if you haven't got access to the API now, it's probably too late. So you'd likely have to do this manually, but essentially you can scrape the data off this website and analyze it and help us understand what the kind of gender breakdown of registered voters is for the upcoming election. And then obviously you can look at it by age as well, and by, it seems, municipality, etc. So you can do quite interesting analysis of what ages are registered to vote by different municipalities and provinces, etc. So that's the one from a voter perspective. The other is we're interested in what candidates are registered for the election. So the new candidate lists for the upcoming election are not yet up. So the data for the 2016 election is there. So it still would be quite interesting to look at what the candidate list is from the previous election, if it's there. Okay, it still seems to be working. So there's a link to that. If you go down this web page on the candidate list, you'll see at the bottom here is a link to an, it's not showing it as an Excel, but essentially says the format is Excel, but it's an Excel file with all the candidates from the last election. So if I just download it, you'll be able to see there's an Excel file with all the candidates from the 2016 municipal elections. I would expect the 29 candidate lists will be up later in the year. So if you're looking to essentially build something that could be used for the new candidate list for later in the year, you can already work with the 2016 database and do some analysis on that. So in this case, you can see there's the name of the candidate is in column E, but then also they provide the ID number and the party, as well as the municipality that they're standing in, and the ward number. So you can get quite low level detail on who the candidates are, and including ID numbers. And why the ID number is interesting, as we've mentioned, is that by looking at the ID number, you can get the age of the person as well as their gender. So you can also do a gender analysis of the candidates that stood in the last election. And if you build a tool, you could do the same thing for the 2019 list when it's released later in the year. We've also suggested looking at issues related to election misinformation, which is an increasingly important issue. You might want to analyze social media to map out who the different kind of groups are on social media that are, I suppose, contesting around different policy positions. There's a couple of links to tutorial and API access on Twitter. And you might want to do things like deepfake detection using kind of an off-the-shelf tool via an API, but that's, I mean, you might be building those kind of things yourself, so that's really up to you, but we just provided some links. Or you might want to get kind of direct government info. And then the last topic we suggested is that after elections happen, the next important thing is how you hold those elected officials accountable for what they do. And one of the big things in South Africa is around audits, and audits are a really important mechanism for checking whether municipalities are performing against what they committed to perform, and also whether their finances are being managed correctly. So if you go to the Auditor General page, the link that we provided there, if you go to one of these, either Annexure 1 or 3, you can get the audit outcomes. It's an Excel file again with the audit outcomes from the last financial year, and you can forget exactly what format they used, but again, it's data that you can play with to compare different municipalities. So they've done their own dashboard, obviously in Excel, but you might be able to develop a more interactive version of this where people could go online, and instead of having to download an Excel file, they can have an interactive web application that helps them understand whether their municipality is complying with their audit requirements and their performance requirements. So you can have a look at that spreadsheet and see if this is something that you could either analyze the data or build some kind of more intuitive interface into the data, such as a web app. So there are a couple of other things. You can look at parliamentary participation. And then the last one, just to highlight from my side, if you're interested in research-related data, there is the SASAS data set, and that looks at things like people's perceptions of different spheres of government and different state actors. So they compare whether they have asked thousands of people around the country whether they trust the police more, whether they trust local governments, whether they trust traditional authorities, or whether they trust churches. And then they've got data that compares people's level of trust in those different institutions. So it's potentially interesting to analyze the data out of that to get a better sense of whether people, for example, trust traditional authorities more than the police or local government. So that's SASAS data. If you want to work with that, you can get in touch and I can help you there. There is a code book which explains the different columns of that data set. And you might need to convert the data set from SAV to CSV if you're not working with Starter and other tools. But you can work with a CSV file and do quite a lot of the analysis from there. As a caveat, it's a nationally representative sample, so you can't really do provincial level analysis, but it does give you some really interesting national level insights into what's going on around the country around perceptions of government. So yeah, as I say, you're welcome to contact me and I can help point you to some kind of support or ideas there. Yeah, so I think that was it. Sorry, just to highlight the last thing is that, which I kind of put up every time, is there's the toolkit, which if you haven't seen before, has links to all kinds of kind of open-ish government data resources. So there's links on the left-hand side that you can click on, which then takes you to kind of categories of data sources. So there are a lot, everything from like election-related links to financial performance, spatial. We really always encourage people to work with spatial data. It's really interesting to work with and actually quite easy to work with. As developers, you'll probably find it quite easy to work with. So we have a mini tutorial on how to work with spatial data that you could have a look at if you wanted to. And you can speak to the Hero Maps team. That's also part of this hackathon, and they can help you work with the Hero Maps tools and also understand the whole spatial data space. So if you haven't worked with spatial data, it might be something you want to try this time because it really is quite a compelling way of working with data and presenting data. But yeah, have a look at the toolkit and you're welcome to ask me any questions if you have any. All right, that's it from me. So I'm going to hand over to Mabu, who's going to do the more hardcore stuff with you now. Thanks. I'll post links in the chat now.
Thank you, Doc. Mabu here. Perhaps let me just show my face a bit as well. So my name is Mabu, as some of you may know. So I'll be taking you through a sort of a technical workshop-ish thing in terms of how you can, what tools are available and some of the things that are important for you to consider when you are trying to build machine learning capabilities into your applications. It's not going to be a deep dive as usual, but I just prepared a few lines of code for us to go through some core concepts. And then I'm going to also just help some developers who are not necessarily having machine learning background in terms of what tools they can use to get machine learning models into their applications. So I'm going to stop my video and share my screen. And please ask questions. Misha already gave us permission to just post the questions in the chat here, and then we should be able to address those for you. Somebody shout when you can see my screen, please. But I think it says you should be seeing it. Anyone? My screen?
Yeah, looks good.
Okay, perfect. So I prepared just a quick Colab notebook here for us to go through what I want to take you guys through. But to be honest, I just want to talk to the tools, but there was certain things that I thought will be important as and when I'm mentoring at hackathons. I see some core machine learning mistakes that some developers make. So I just wanted to clarify one of them now, and then we can go into the tooling and what tool sets you can use. So I'm just loading an iris dataset here for the purpose of my demonstration of what I want to talk to you guys. But one of the most important things is that when you're building a machine learning model, there is this thing called sampling. So usually, like most people would remember sampling from just train test split, where you from sklearn.model selection import train test split, and then you will split your data into training and testing. But there is something very, very important that I've seen people ignore. So for example, typically in the real world, you would have, so from a point of data sets, there is this concept of a balanced data set versus an imbalanced data set. So in the real world, when you're working on machine learning, usually data sets are almost always imbalanced, where you have like maybe 90% of the examples in your data set are belonging to one class, and then the rest are belonging to other classes. And that is called it's called an imbalance. So for example, this thing here, it's typically called a balanced data set, where you can see these are all the target labels in my data frames that I'm trying to predict, right? And then you can see that this is the iris data set, so you'll be familiar with it. So the Setosa, Versicolor, and Virginica is types of flowers. So you have 50 examples of each of these things in the data set. So that will be called a balanced data set. So once you have a balanced data set like this, it tells you a bunch of things about what you can do with your data. One of the most important things it tells you is what metric you can use for evaluating your machine learning model. So most people, when they build machine learning models, they always jump to accuracy, right? I mean, in all hackathons I've been, hackers report accuracy as their metric. And to be honest, accuracy is not always a useful metric. Oftentimes, actually, in practice, in enterprise, we barely ever use accuracy as a metric because it doesn't tell us a lot. Because of the nature of how accuracy is calculated, which you can look it up on Wikipedia or whatever, with true positives and true negatives and whatever, it doesn't capture the essence of the distribution of the dataset itself. So like I'm saying, I build a lot of models in my job, and I've never actually used accuracy as a reporting metric. There's always like some fancy metric, whether it's an F1 score, precision, a Matthew correlation coefficient, or that type of thing. So accuracy is barely used. So I just want to talk to you guys about why you should consider how you measure your machine learning model, because what ends up happening is that you built it, you train it, then when you report it to the judges and when you're presenting, you're like, yeah, my machine learning model is 87% accuracy. It's like, okay, can we get a sense of what data set it came from? Because then if the data set was imbalanced, then your accuracy is useless, you know? So there's important considerations when you do that, but I'll just try to talk to you guys through that quickly. So what I did here is just try to make this class imbalanced a bit. And actually, I think I should make it even more imbalanced so that you guys can get the picture. Okay, so now we've got a data set. So we went from all of these classes having 50, 50, 50, and then you have this one with 20, 30, and 50. So this is a bit of an imbalanced data set, right? Because then you have this one with a almost 2 times more than the number of examples that this class has. So it's imbalanced. And then in scenarios like this, when you use accuracy, you may find that the only thing your model is predicting is this thing with 50 examples. And because of the nature of accuracy, when you're counting those number of 50 examples, it will just shoot up the accuracy because you got those 50 right. And it doesn't account for the fact that the imbalanced data sets may not be predicted at all. This is deep and very technical, but I'm just going to paint the picture, and then you guys can do some additional research on top of this. But I'm hoping that after this workshop, when you guys report the metrics of the performance of your models, and you take into consideration the distribution of a data set into consideration, and we'll hear people reporting different metrics rather than just saying 88% accuracy or 90% accuracy, because it doesn't always mean anything. Okay, so then you have that. So now we can take our train test split as usual, and then we're going to split this thing. The next thing I want to talk to you about after the accuracy thing, I'm going to come back to the accuracy thing quickly when I show you the metrics. But the next thing I want to show you about is this thing called sampling, right? So in machine learning, sampling is very important. Sampling is very important in any statistical approaches. And if you did any statistics class, you would remember your sampling methods, right? There is sampling theory in statistics, and they'll talk about random sampling, stratified sampling, random sampling with replacement, all those core concepts. Those things are super important in machine learning. One of them is actually just this basic example. So think about it this way. We have this imbalanced data set, right? So that means that when we do our train test split, and then we want a training set and a test set, we have to make sure that 10 of these very vesicular examples are in the test set, and then 10 of them are in the training set. Or even when you're still at the validation set stage, imagine that this test set was a validation set. So you want that. The reason that is important is because if these things are, if say for example, you don't when you sample, you don't sample properly, you could end up with like only 2 examples of vesicular in the training set and 18 of them in the test set, right? Because you're not, just like sampling, right? When you're sampling, you need to make sure that you sample equally. So if I say to you that, can you generate a sample of males and females in the population, right? You want to make sure that the males and females in the sample you generated are representative of the population. So you don't want to end up with the data set with a sample. When I said sample males and females from the South African population, you don't want to end up with a data set that says in your sample you've got 1,000 males and 500 or 200 females. That is not the representative of the real world or the real population. So that is why it's important for you to consider these things when you're doing sampling. So for example, if we just run off with this and say, okay, from sklearn import that, and then say train test split, and then we give our test set size, like 10% of the data, then what you end up with is something that looks like this, right? So if you look at the distribution in the training set, so 50% of the training set is Virginica, right? And then Setosa has like 28%, and then Vesicular has 21% in our training set. And then in our validation set or test set, because I'm using them both as the same thing here, you can see we have 50% of this is Virginica, 40% of it is Setosa, and only 10% is Vesicular. But we had 21% in here, and we have 10% here now. We had 28% in the training set, but now here it's 40%. You see now, when we validate our model, we're not actually validating it in the true reflection of the distribution of the data set, right? This is a very, very, very important consideration. It can make or break any of your machine learning efforts. So now let me just show you how you can handle this. So train test split actually comes with a very underappreciated parameter called stratify. People seldom use this, but it's important and it's there for a reason. So stratify is just saying that when we're doing our sampling, we're not doing random sampling. We're going to do sampling in a stratified way. So it's called stratified sampling. You can look it up. What it means is that we're going to make sure that these things, like I said, we probably want to make sure that 15 of these things are in the training set, 20 of these are in the training set, 25 of these are in the training set, so that we have an equal representation. Even when we test our model, it will be being tested on classes that are balanced as per the original data set you were given. Super important. So notice what happens when I say I stratify by my class label, right? When I do that, now the distribution of my test set and my training and test set will be the same. You see? So now I have 50% here, 30 and 20, 50% here, 30 and 20. So now I'm doing what? Apples compared to apples, you know? So I'm not telling people that, yeah, my sample says there's 1,000 males and 20 females in South Africa. It's like, really? That doesn't represent the distribution of the South African population. And for that reason, your sample is not reliable for any statistical or scientific study. Okay? Very, 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 very important. So now, and also, by the way, this affects your model performance. So if I just train the model without stratified sampling, the performance is very different. And I'm going to share the link of this collab so you can just play around with these ideas. Okay? So, but now let's just build a dummy model. I'm building a decision tree classifier, right? And then now I want to talk to you about model metrics and why the shape or the distribution of your data set dictates how your model behaves, and how metrics can be misleading if you didn't account for the distribution of your data set, okay? So I'm gonna instantiate my classifier. I call my dummy model. It gives him an accuracy score and predictions that it made, okay? Then I go to sklearn, I call that, this is the accuracy score, right? 100%, right? 100%, the model is 100% accurate in predicting these things. That's what this dummy model of mine is saying, okay? And then, very important thing to do all the time is to use this thing called a classification report, right? A classification report. Classification report is going to be able to tell you for each class, how is the model doing, and on very core important metrics. So just saying from sklearn and say metrics.classification, I mean, .accuracy score and say it's 90% is not enough. It is almost never enough. You need to get a deeper level of this. But for me to make my point, let me make this model not 100% because I don't want it to be 100% to give you the idea of what I'm saying. So let's go ahead with this, the poor sampling technique, and then instantiate the model and then get that. And then let's see what our accuracy score is. Yeah, and notice how it just went to 90, but I didn't change anything. The only thing I changed was my sampling strategy, right? And my model goes to 90 after it was 100% accurate. So very, very important considerations to make. And you can see now that it says it's 90%, right? But if you look at this, look at how poor the model is at recognizing these things. And part of the reason is because I didn't use a proper sampling strategy. Now I only have one example in my validation set of this class. That's very not. And then you're telling people that your model is 90% accurate, but that time there is only one example of the other class in that model. You really can't say it's 90% accurate if you have only one example, right? But usually people say that and they do that because they're just missing the point of your sampling strategy and how it affects your performance. So if you look at this, so now we have this and you can see that the precision is 50%, F1 score is like 6. So it's not at all, this 90 does not at all represent this class that we're dealing with, okay? And also, by the way, this 90%, because of this imbalanced data set, is not telling us the truth. So like, yeah, I just made that point now. It's not telling us the truth. So what can we do to actually get the truth? So usually there is a metric called Matthews correlation coefficient. It's a metric that's suitable for imbalanced data set. So it's more like, it's like accuracy that went to private school. So it accounts for the distribution of the class labels in the data set. So if I calculate the Matthews correlation coefficient for this thing that has a 90% accuracy, it goes down to 85%. So for me, if I'm reviewing your model and I appreciate that there is imbalance in it, I'm going to want the Matthews correlation coefficient as the score that you say you measured the model against. And if you were excited saying that it's 90%, and then I just say this, I say, okay, you lost 5%, brother. So now this doesn't qualify anymore to go to production or something like that. Very important considerations. And yeah, notice how now, if we just change our sampling strategy again, we're going to get a better model, right? We're going to get a better model in many different shapes. And also there you go. The MCC will also be now accounted for in terms of the class distribution of these things. There is another important thing that I don't have here, and I don't think I'll have time to go into. But then also what happens is that once you do this, once you measure the performance of your model on the test set, you need to also measure the performance of your model on your training set. I'm sure most of you would have heard about this thing called the bias variance trade-off. So usually what would happen is that you may find that the model is saying I'm performing on the training set is like it's 90%, but then on the test set it's like 40%, or maybe it's like 80% of the test set, and it's on the training set is like, I don't know, 60% or something. All of those things tell you something about your data, you know. And you always, once you build a model, the first thing you want to investigate is two important features: am I underfitting or am I overfitting? Oftentimes you're doing one of them, right? It's very rare for you to just get it to work. By the way, this one is a nice data set. It's an iris data set, so it's an easy thing to do. That's why you're getting 100% accuracy in this. But in a real world data set, you wouldn't get something like this. But every time you're training a model, it's either you're underfitting or you're overfitting. So the first thing you want to do is test which one are you doing, and then work with it. Okay, if you're overfitting, you regularize. If you're underfitting, you make your model bigger or add more data, that type of thing. So there's always strategies to deal with those things. Very, very important considerations. Okay, so now I'm gonna get into like developers who don't know how to build machine learning models, right? Or don't have time in this hackathon. There is this platform called Teachable Machines by Google, which is a no-code machine learning training model. It allows you, but it actually just works for CNN. So for now, I think the only thing it supports it's image data. So you can't do this with text or whatever. But then what it allows you to do is just to come here, say get started, upload the data set, right? Then I'll choose here, yeah, you can do pose recognition, you can do audio projects, you can see they support that now, and then you can do an image project, right? You go to an image project, and now you can upload the data set, right? You upload a data set, yeah, you upload the data set, so class 1, you can call it, maybe it will be like, I don't know, it's whatever you're classifying, right? Class 1, class 2, class 3, class 4, blah, blah, blah. Once you upload the data set, you can train the model, then export the model. When you export the model, you can be able to serve that model with a RESTful API, or you can consume it in TensorFlow JS, or even in TensorFlow Mobile with model quantization and other fancy stuff, okay? So if you want to build something that's related to a machine learning model that understands or analyzes images, and then you don't have the time to train the model, or you don't have the competency, you can use something like teachable machines for you to just train that by just feeding it examples and then having a model on the other side. Very important and very nice, meant for developers really. So because once you export it, they're going to give you like things like the code examples to say this is how you integrate it into a. I don't have time to upload the data and try to show it now, but you guys can just go to this teachable machines thing and try it out. Okay. So beyond Jupyter notebooks, another thing that happens is that models are usually trained on a Jupyter notebook or a Colab, like I am here, using like some free GPU or some fancy TPUs that are also free to train a very competent or a very performant model. But that's not the end. Models need to get out of the notebook, right? They need to be serialized and then integrated into an operational system. Models are useless if they are in a notebook. They're not useful at all. They're not useful to us, right? A model should get out of the notebook and then be able to be served, right? Either integrated with the mobile application, integrated with the website, integrated with whatever it is that you're integrating. That's only the time a model is useful. When it's in a notebook, useless. It's just fancy Python code, okay? So the way you do that obviously is by what is this? Serializing your model so that you can consume it with other upstream applications, right? Usually serialized models are application agnostic. You can load it with C#, you can load it with Python and that type of thing. But there are other industry grade saving pipelines. TensorFlow has a very fancy one. PyTorch also has one, but where you can do model saving. So once you build your model, you can save it in something called a saved format. Actually, this architectural overview will be nicer. You'll have something called a saved format. Then once you have a saved format, okay, this is a bit more complicated. Once you have a saved format, then a saving instance of TensorFlow can do that. And then it's going to spin up a Docker container. There is a Docker image that you can pull for TensorFlow saving. And then you can spin up a Docker container that has your model in it. And then all you do now, it's you send RESTful request to that Docker container, right? Send RESTful request, you move a get, and then you get a prediction. Post, you get a prediction, whatever it is that you're exposing your things with. So all the documentation is here for how you can build the prediction scripts and stuff like that. Or you can even have the server API itself. You can use this, where you can use some gRCP, fancy loaders and stuff instead of just RESTful stuff. You can use those, and you can also use it as an API. So you can use it you can import TensorFlow, and then the saving API will know that you are instantiating a model somewhere, and then it's going to do that for you. Okay, but it's important to save models, because remember, a model, if it's in a notebook, is useless. It's not doing anything. Okay, but there's other stuff where you can build like model saving UIs without HTML, without writing HTML code. I've spoken about this before. So Gradio is one example, which is great. This one is a digit recognizer, right? So you can you build a digit recognizer, then you want people to play with it. So you see, if I say 7, it's predicting that this is a 7 with 99%. You see, if I do that, it says it's 2. It's a misprediction, obviously, because it's supposed to be 8, right? So that type of thing. But then the point is, once you have a model, you can use Gradio to serve that model. If, let's say, you're predicting, it's an image classifier or something, you can use Gradio to say, okay, upload the images here, and then I'll predict for you in the background. And all you have to write as code in Python is this for Gradio. This is all you have to write. This is your own implementation where you're saying that what should my model do when it receives an image, right? There is some pre-processing, whatever, then you do that and then you predict. But Gradio is going to take care of the whole thing for you. It's going to spin up the HTML UI for you. It's going to do the rest. And then your model now has an interface where when you're demoing even to judges, you can say, for example, if you did this, this is what's going to happen. Everything works on PowerPoint. So we don't want demos on PowerPoint. Your demo should be real-time demo, and then there's tools like Gradio that can help you do a very beautiful real-time demo that's going to be very convincing and helpful. You can also do this one. This one is for image segmentation, is an example. So if I do this, and I take a picture of me, so it's supposed to segment my face with using this thing called semantic segmentation. There you see, so there is a model in the background, there's a neural net, and then it's segmenting my face like that. But all I had to do is this. So you only implement the segmentation function. Say, when my segmentation model receives an image, what must it do? Okay? You can do this with Q&A stuff, NLP models, and stuff, and other things, right? For example, this one would be a typical model. I think it's saying it's a forecasting model. So let's say you build a forecasting model, it's a regressor, linear regressor, or maybe you're using Prophet. You can use Gradio to make sure that you can serve those models, and then give people the ability to say, on the judge to say, yeah, so let's say you were born in January, and then the model is going to predict because. You get it? So that's the point is, have an interface where you can serve your model if it's not integrated in an application. Okay. So, but usually for hackathon, you need to operationalize. So you really need to integrate them with an application, maybe mobile app or a web app, whatever it is. Streamlit is also a useful tool for that, for saving models, right? It's also, Streamlit is useful for saving models. You can look it up as well, and then play around with that. Okay. But then before I run out of time, there's also low code machine learning tools. So for example, say that you cannot afford, maybe the model you're building is not a model for images, or it's a text model or something, and then teachable machines can't help you or whatever. Then you need to build a model from scratch, or maybe using pre-trained embeddings or pre-trained weights from an image classifier. I don't know. Whatever it is that you're doing, you can use low-code tools. TensorFlow it's fairly low-code, but it's not low-code enough. Also, TensorFlow is integrated with Keras, so you can also use Keras by just going to Keras here. I'm sure you know about Keras. Build a very simple model. Simple Python code, very powerful outputs, and that's the basic concept. PyTorch is also nice. PyTorch, I like PyTorch Lightning and PyTorch Lightning Flash. So they are high-level abstractions. You can see that for PyTorch Lightning, it's going to take this complicated code and reduce it to this small, very structured Lightning module, right? So you go from here with training loops where you have to for loop from your epochs and stuff, and then you go from that type of vibe to just something very simple in PyTorch Lightning. Something very, very simple. Very, very simple. You can look it up here, very easy to get started. But you can also use PyTorch Lightning Flash, one of my favorites. I'm actually a contributor to this package because I love it so much. So I love it so much that I use it a lot, so I have to contribute to it. This one is actually much more hectic. It's very high level. So for example, this is a translation task. So you can imagine you wanted to build a translation model, and then all you do is take the model checkpoint. I mean, the checkpoint isn't like the weights which you want to fine tune, right? Then you can even just predict without fine tuning, but you can also fine tune by giving it your own data set. So whatever you're working on, this is just a translation. There is a lot of other things. There is an example for image embedding. There is an example for text summarization. If you're summarizing some government document somewhere, don't know what you'll be doing. And there is tabular classification as well. So if you have a traditional tabular data set where you're just doing classification or regression for that matter, you can also use a high-level tabular class. This is PyTorch is from Facebook, and PyTorch Lightning is being maintained by Facebook and other people. So this is a very important thing that you must take seriously. Then yeah, so those are low code, but there's also model quantization stuff. I left an example thing here. I'm going to share this link. There's model quantization stuff where they show you how to use TensorFlow Lite, for example, to deploy your model into a mobile application. So for example, this is called edge machine learning. So if you want to do machine learning on the edge rather than make API calls, especially for safety, for security, for privacy and stuff like that, you can just make sure that you do the inference on the device rather than do the inference in the cloud or on some server somewhere. Very, very useful thing. You must check it out. Model quantization, you can go here as well. You'll get an introduction to TF-Lite. So the idea is that you have a TensorFlow model, then you convert it to TF-Lite. Then now iOS, your Android, and other Raspberry Pis and stuff like that, they will be able to read the model and then do predictions on the edge. So I'm running out of battery before it dies. So okay, the last thing I wanted to talk to you guys about, okay, transformers as well. So if you're working on text, and by the way, what I've noticed is that hackers are especially in the context of machine learning and data analysis and stuff, they are running away from text because usually text is known to be unstructured and difficult to deal with, right? People want to predict images or they want to predict on a tabular data set because it's easy. But there is powerful ways you can use, there is powerful libraries you can use to really deal with text. This one is my favorite one. It's called Transformers. Transformers has this high-level API called pipelines. And what that thing can give you is that with pipelines, you can like sort of do sentiment analysis out of the box. You can do a question answering out of the box, summarizing text out of the box, generating text out of the box, right? You can do translation out of the box if you wanted to, if you're working on text data in the government context. My favorite one is this one called Zero Shot. Zero Shot, you don't even train the model. What happens is that there is a pre-trained model in the background, and when you do zero shot learning, you just give it examples and you say, classify this stuff, right? Imagine you were doing some sentiment analysis on Twitter or something like that, and then you just say, classify. Okay. Okay, my audio is back, I hope. So you don't need to do any code. I'll give you this example. This example is a Colab thingy, Google Colab notebook. You just pip install transformers, yes, and then from transformers you import pipeline, and then you instantiate a zero shot classification pipeline. And what you do is that you say to the zero shot classifier, this is the list of topics I want you to classify, and this is the text I want you to classify, right? And then it's going to take this and it says, is it an IT issue, price request, or daytime request? And then you predict. And you see, without training, this text, computers are slow, is being predicted as an IT issue, right? You didn't train anything. And also, by the way, this is less than 5 lines of code. And you have a very viable machine learning model that you can work with on text data. Whether you're analyzing tweets or you're doing whatever you're doing, you can actually use these high-level pipelines to do that type of thing. Okay, so we spoke about TensorFlow, PyTorch, and transformers, images, tabular dataset, and including text. So now you can use some of these tools to build whatever it is that you're working on. And also, I left an extra information here where I gave a presentation in the previous workshop for the Nemisa Hackathon about how you can use some data science tooling, including deploying a Gradio app, deploying a Streamlit app. I have examples of those, and you can find all the examples on the GitHub repo here. Okay, so yeah, I think that's it for me, and I'll see if there's any questions or any clarity that's required. So, not really. So the 100% is not a sign of overfitting. The iris dataset, because it's not overfitting because I'm testing it on the test set. So you can't overfit the test set because you didn't train with it. But the iris dataset is a very standard dataset. So it's expected to be very performant. Even a basic model will just be very good on the iris dataset. It's usually used for introduction to machine learning. It's like that one for digit recognition. So it makes sense why it's okay. Focusing on machine learning at the time. Please share the code, the link, just fancy Python code. You are moving too fast. Askis, I don't have enough time, but I'm gonna leave the Colab for you guys so you can just go through the topics. And all of this, I'm a mentor, so you can always ping me to clarify anything that you haven't gotten properly. Please share presentation slides. Okay, they are not slides. It's a Colab notebook. I'll share the Colab notebook. Okay, I think that's all the questions we have. I hope this was useful. But yeah, if there's any other question, I can take it. Otherwise, I don't know, Dr. Paul, I think this is where it ends because it's almost 12. It is after 12.
Thanks, Marvel. I think we're handing back to Misho, if he's still there.
Okay. Which he isn't.
Yeah, I think, yeah, if there are no questions, I think that's it. Yeah, as Marvel was saying, both of us are on Slack most of the time. So you're welcome to just send out a question. We can get back to you if you've got any. So yeah, I'm not sure if Misha was planning to do anything after this. Maybe I should message him quickly. Otherwise, I think that's it. I'm going to WhatsApp him, but as far as I know, that's the end of the session.
Cool. Thank you, guys. I hope, yeah, if you have any question, reach out to me and I'll be available. But yeah, thanks for listening.
Said that you obviously use
Hi, Mabu.
APIs to identify the location, and some of your users are adding in locations that are missing.
Mabu?
Would that be correct?
So I'm using the map and then